Hello, this lesson is going to be lesson 2.4a. It's a two-part lesson. We're still on scientific notation. Now we're going to do the hard stuff with scientific notation. So far, I think you've been feeling it's been pretty easy. Now, when we get to adding and subtracting, which is what we're going to be doing, it can be a little bit confusing. So let's take a look. You'll get it just fine, though. So adding and subtracting with scientific notation. The standards we're going to be working in, I can add numbers written in scientific notation, and I can subtract numbers written in scientific notation. Why would you want to do this? Because sometimes the numbers can have whole bunches of zeros, right? They can be super huge. It might be easier to add and subtract them in the short version form of the scientific notation. And our EE4 is our standard, perform operations with numbers expressed in scientific notation. Those operations today are going to be adding and subtracting, including problems where both decimal and scientific notation are used. Use scientific notation and choose units of appropriate size for measurements of very large or very small quantities. We've looked at both now. We're going to interpret scientific notation that has been generated by technology. So let's move on. Here's my math meme for the day. Gorilla is so fat, he expresses his weight in scientific notation. Okay, continuing on. Oh, I'm going to minimize myself so you can see the whole screen. Adding and subtracting numbers in scientific notation. There are two ways to add and subtract numbers in scientific notation. The first way is method 1. It's called adding the scientific notation numbers. And the second method is going to be rewriting the scientific notation number in standard form and then adding or subtracting. You can do either. You can do what you're most comfortable with, but I do want to show you both methods. Adding scientific numbers. Method 1. Okay, here we have the population of the United States, Canada, and Mexico. I believe these were the numbers in 2011, so I'm sure it's more than that now. However, this will work. They're both are all triple huge numbers. So the table shows the population of the 3 largest countries in North America. Find the total population of these countries. When you hear the word total, it makes you think of adding, correct? So we're going to be adding. So step 1, we're going to write each number with the same power of 10. When you add and subtract scientific notation, you have to have the same powers of 10 before you can add or subtract them. Okay, so that's something important that if you forget, your answers are going to be wrong. Okay, and it's kind of like if you think about fractions, when you have different denominators, they have to be the same before you can add or subtract them. It's the same with scientific notation. Only in our case, it's the power of 10 that needs to be the same. So if you look up here, this is 10 to the 8th, this is 10 to the 7th, and this is 10 to the 8th. There's one odd duck out. Do you know which one it is? Yeah, 10 to the 7, Canada. So we're going to have to change 10 to the 7 to match the US and to match Mexico. Since the US and Mexico each have the same power of 10, we only need to convert Canada's power to 10 to the 8th power. How do we do that? Canada, I gotta move my little toolbox here. Canada's 3.38 times 10 to the 7th, but we wanna make it into 10 to the 8th. Hint, hint, we're gonna have to do something with the decimal point. What do you think we're gonna have to do? Well, we're gonna find out. The suspense. Okay, there it is. How do we rewrite it? To convert scientific notation to another power of 10, we need to get it into 10 to the 8th power. We're going to decide how many decimal places to move the decimal. Did you say move the decimal? Were you thinking that? And then we move the decimal. So we're going one place up. We're going from 10 to the 7th to 10 to the 8th. So where are we going to move our decimal, left or right one place? Since we are at 10 to the 7th and we need to get to 10 to the 8th, we need to move the decimal one place because 7 to 8 is one spot, right? From 7 to 8, you're going one unit. Because we are increasing the power from 7 to 8, we move the decimal left. In this case, 1 space, because we're increasing by 1 power. If we were increasing by 2 powers, let's say we wanted to do 10 to the 9th, which I don't know why we'd want to do, but if we had a different scenario where we needed to do 10 to the 9th, we would need to move the decimal place 2 to the left. Here's a suggestion I have for you when you're doing these problems. They can get confusing. What you need to do is always try to pick the number with the power that's lower and move it up. That way you don't have to remember which way to move the decimal. Because if you were moving 10 to the 7th down to, like, say 10 to the 6th, then you'd be moving your decimal to the right. So if you want to keep it straight, always try to increase your powers of 10 and think, I only have to move the decimal to the left. Otherwise, you can get all confused. There we are, our little arrow, moving our decimal 1 place to the left. And increasing our power to 10 to the 8th. So now it's 0.338 times 10 to the 8th. So you'll see that right here. We just moved our decimal 1 place and we increased our power of 10 by 1. So step 1 was to write each number with the same power of 10. We just converted Canada. Step 2 then is to add the multipliers. What are the multipliers? Well, the multipliers are the numbers in front of the power of 10. They're just called multipliers because we're multiplying them times the power of 10, right? So those are our multipliers. So now since we want to add all 3 countries, we're going to add 3.1 and 0.338 and 1.1. Why did I say 0.338? Write that up here, even though it'll come up in our screen here in a minute. Because we changed this, right? This is now 0.338 times 10 to the power of 8, because we need the powers to be all the same before we can add them. So that's what we're doing. Okay, see how that works? The US is 3.1 times 10 to the 8. Canada, remember we changed it, 0.338 times 10 to the 8. And Mexico is 1.1 times 10 to the 8. Notice how I am lining up my decimal points as much as the computer will allow me so that we have them in the right order when we add them. Remember to line up the dot and give it all you got when you're adding decimals. Okay, so when we add that up, the little plus sign there and the line below it, we get 4.538. 8 plus nothing is 8. Oh, my black bar is going to show at the bottom. I don't like that when that pops up like that. I don't think there's any way to get rid of that. 3 plus nothing is 3, and then 1 plus 3 plus 1 is 5, and then 3 plus 1 is 4. Put the decimal in the same spot as it is in the other numbers, 4.538. And what do we do about the power of 10? Easy peasy, times 10 to the power of 8, because we keep the same power, right? So step 3, we're going to adjust the final answer to scientific notation if necessary so that the multiplier is between 1 and 9.99. Well, 4.538 is already between 1 and under 10, correct? So we do not have to adjust this one, but note, you will be adjusting some of the numbers in your final answer when you say, for instance, you got, instead of, that black bar is there again, instead of 4.538, let's say you had 45. Let's say the answer was 45.38. Okay, let's just say that was the answer. If that were the answer, which it isn't, but if it were, which it could, different problems, you're going to need to move the decimal 1 to the left and change your power of 10 before you have the final answer, okay? In our case, we don't have to do that in this problem. So our final answer then, and I'm going to clear my drawings, is 4.538 times 10 to the 8th power, right? Keep the same power of 10 unless you have to move the decimal to get it into a number between 1 and under 10, okay? Method 2 to add scientific notation numbers is to write them in standard notation. So we have the same numbers there. Same United States, Canada, and Mexico populations. So we're going to find the total population. So step one is going to write each number in standard notation. Standard is the way numbers normally look, right? 3.1 times 10 to the 8th. We're going to move our decimal 8 places to the right. 1, 2, 3, 4, 5, 6, 7, 8. Fill in our empty spaces with zeros, and you'll see the result is 310 million. Second one we're going to write is Canada. We don't have to change the power of 10 this time because we're writing it in standard form. So again, we're going to move our decimal place 7 spots to the right. 1, 2, and keep going. 3, 4, 5, 6, 7. That will result in the number you see right here, 33800,000. And then we've got Mexico, 1.1 times 10 to the 8th. And there's the number. If you move the decimal 8 places to the right, get 110 million. Now that we've written the 3 populations in standard notation, we then put it back. We find the sum of the numbers in standard notation. So how do you find the sum of numbers? You add them up. So we then add them up. And we get 453,800,000. But then we need to write the answer in scientific notation. How do I do that? Well, I start with the decimal at the end, and I'm counting how many jumps I'm making. 1, 2, 3, 4, 5, 6, 7, 8. I'm going to put it right here, the decimal, because that's a number between 1 and 10, or 1 and 9.99. So the answer will be 4 point, and it'll come up in a minute, 4.538 times 10 to the what? If you forgot how to do this, then you can go back and watch the previous 2 videos. 10 to the what? How many jumps? 1, 2, 3, 4, 5, 6, 7, 8. 10 to the 8th. So 4.538 times 10 to the 8th. Same answer as we got the first way. This is just showing it to us another method to get there. In math, there's several ways sometimes to get to places. So there is our answer. The total population is 4.538 times 10 to the 8th. Okay. At method 1, adding scientific numbers, we're going to show you another example here. We're going to add 2.3 times 10 to the negative 2. Times 4.5 times 10 to the negative 3 plus 6.1 times 10 to the negative 2. Okay, we're looking for the odd duck. We have a negative 2. We have a negative 3. We have a negative 2. Who's the odd duck? Right, 4.5 times 10 to the negative 3. And remember I said if you can increase the powers, it's better and easier than trying to decrease the powers. In our case, negative 3 is smaller than negative 2. Think about it on a number line. Negative 3 is to the left on a number line, so it's a smaller number. You'd rather owe somebody $2 than owe them $3 because you owe them more money, right? You'd be more in debt, but you would be at a smaller income level, so to speak. I don't know if that was the greatest example, but you want to change negative 3 and you want to increase the power to negative 2. So write each population with the same power of 10. Remember, you can never, never, never add or subtract numbers in scientific notation unless you have the same power of 10. Don't forget that. We need to rewrite 4.5 times 10 to the negative 3 to the power of negative, to the power of negative 3 to be the same as the other 2 numbers. Yes, so we have to do it to 10 to the negative 2. 4.5 to 10 to the negative 3 equals, how do we do this? Let's go to the next screen. There's our numbers again. How are we going to do this? We're going to move our, hint, hint, yes, our decimal to convert to another power of 10. Decide how many decimal places to move the decimal and move it. So if we're going from negative 3 to negative 2, how many spaces is that? How many units? 1 unit. So our decimal is going to move 1 to the left because we are increasing the power of 10. Even though it seems weird that we're going to negative 2, we are increasing it. since we, what does this say? Since we are at 10 to the negative 3 and need to get to 10 to the negative 2, we need to move the decimal 1 place. Because we are increasing the power from negative 3 to negative 2, we move the decimal left 1 space and decrease the power by 1. I should say, yeah, that's correct. Increase, not decrease. I have the wrong word here. This should say increase, not decrease. I will fix that. Every once in a while when I'm making these slides, I make a mistake, and that's okay. So increase the power by 1. So we're going to be moving our decimal place 1 this direction. We're going to be changing this number to negative 2. So let's have the computer do it for us. Here we go. Move it 1 to the left. Change it to 0.45 and 10 to the negative 2. So we've rewritten now. All 3 numbers are in the same power of 10. So we write each population with the same power of 10. That's done. We add the multipliers. What are the multipliers? The numbers in front of the powers of 10. 2.3, 0.45, and 6.1. Notice how I used 0.45 because I changed the number to the same power of 10. Look how I'm also lining up, to the best of my ability with this computer, lining up my decimal places. Okay, they are lined up. That's how you have to do it when you add decimals. Then I add them together and I get 8.85, and it'll be times 10 to the negative 2. Then I have to ask myself, is 8.85 a number between 1 and 9.99? And I would say, yes, it is. So I don't have to do the final step. I don't have to adjust the final answer to scientific notation because my multiplier is already there. So the final answer is 8.85 times 10 to the negative 2. Hopefully that makes sense to you, because now I believe you're going to get a chance to try it. Nope, well, we got to do method 2, then you'll get a chance to try it. So we're rewriting it in standard notation if you prefer this method. Same numbers. We're going to write each number in standard notation. 2.3 times 10 to the negative 2. Remember now, because it's to the negative 2, we're going to go to the left with our decimal 2 spots. 1, 2. If you forgot how to do that, that would be the last lesson. So that's where we get the 0.023. 4.5 times 10 to the negative 3. We've got to go 3 places to the left, 3 jumps. 1 jump, 2 jumps, 3 jumps. Fill in with zeros. There's our decimal now. Fill in with zeros. Okay, that's where we get our 0.0045, and then the final one is 6.1 times 10 to the negative 2. That moves the decimal 1 left, and then we just add our numbers, our multipliers. So let's go to that screen again, add our multipliers, and we get 0.0885. Ah, that's not between 1 and 9.99. So we do have to do the final step, write the answer in scientific notation. How do we do that? We need to get this number to a number between 1 and 9.99. Let's move our decimal. Where, how many spots? 1, 2, right? Because now we have 8.85, and that's between 1 and 9.99. So it's going to be 8.85 times 10 to the what? Well, we moved right this time. So we moved 2 spaces, 10 to the negative 2, right? And that's what we got on the first answer, the first method. We're going to get it again on this method. So we can have the computer do it for us and show us the final answer of 8.5 times 10 to the negative 2. Either method got you to the answer. You can choose the method that you like better. And now you get a chance to use the method that you like better. See you in a moment. Okay, welcome back. Hopefully you did well in adding with scientific notation because now we're going to go on to subtracting with scientific notation. So method 1, we're going to subtract the scientific notation numbers. In method 2, you're going to be subtracting the standard notation numbers. So let's see the steps, very similar. This time we want to use the same table, but we want to find how many more people live in Mexico than in Canada. When you see how many more, that is a key phrase for word problems that mean to subtract. So we want to find how many more people live in Mexico than in Canada. We're going to be subtracting the Mexico and Canada numbers. So step 1, we have to make sure we write each number with the same power of 10. Since we only have to do Canada and Mexico this time, I still would like to, I could go either way, right? I could write Mexico as 10 to the 7th power, or I could write Canada as 10 to the 8th. I said it's much easier if you go up and increase your power than if you decrease your power, because you have to remember more things if you do both. So we're going to take Canada and move it up to 10 to the 8th power, because then we know we have to move our decimal to the left to do that. Okay, and we're not confusing ourselves. Convert Canada's power to 10 to the 8th. We're moving it up. We're increasing it. So how do we do that? Remember from the previous slides, how do we do that? Write each number with the same power of 10. We're going to move the decimal one place to the left because we're increasing it by 1 power. When you increase, you move to the left. So let's see that in action. Decide how many decimal places to move the decimal. We decided it was 1. We need to move it 1 place. Because we are increasing the power from 7 to 8, we need to move the decimal left 1 space. Left. Think about, you increase the power, you move the decimal to the left. Okay. There we are, moving it. And now the new number becomes 0.338 times 10 to the 8th power. Now that they are both in the same power of 10, we can subtract them. How do we do that? We subtract the multipliers, the number in front of the power of 10. Subtract the multipliers. We have 0.338 times 10 to the 8th, and we have 1.1 times 10 to the 8th. Notice how I put Mexico on the top because that number is bigger than Canada. If I was to do it the other way and put Canada on top, I'd end up with a negative number. We don't want that. We want to put the bigger number on the top. Then I subtract, and I get 0.762. And 0.762 is not in standard or in scientific notation because it's not a number between 1 and 9.99. So I need to do what? I need to get this decimal moved so I do get a number between 1 and 9.99. I'm going to put it right here, and now I'll have 7.62. But what do I do with the power of 10 when I move my decimal 1 place? We decrease the power of 10, right? 7.62 times 10 to the 7th. We had to decrease it by 1 because we moved our decimal 1 to the right. Remember, your powers of 10 decrease when you move to the right. Your powers of 10 increase when you move to the left. It would be a great thing to write down. If you increase your power of 10, you move the decimal to the left. If you decrease your power of 10, you move your decimal to the right. I'll let you pause the video and write that down. Post it on your mirror, post it on your bedroom walls, post it in your classroom so you remember. Okay, moving on. We're going to rewrite our numbers in standard notation and use that method. Here's the same problem. How many more people live in Mexico than in Canada? We're going to write each number in standard notation. So Canada, that's 3.38 times 10 to the 7th, which we saw in our earlier slides is 33,800,000. And Mexico is 1.1 times 10 to the 8th equals 110 million. That actually should be above Canada. Hopefully I did that on the next slide. Let's see. Yep, I did. So we're going to subtract. Why are we putting Mexico above? Because it's the bigger number. And we're going to find the sum of the numbers. Not the sum. We're going to find the difference. See, I forgot to change my slide. We're going to find the difference of the numbers in standard notation. So if we subtract those, we get 76,200,000. That's how many more people live in Mexico than in Canada. And then we're going to write our answer in scientific notation. How do we do that? We have to get this to a number between 1 and 9.99. So right here is where I want to move my decimal. It starts at the end. 1 jump, 2 jumps, 3 jumps, 4 jumps, 5 jumps, 6 jumps, 7 jumps. 7.62 times 10 to the, how many jumps do we do? 7, right? 10 to the 7. 1, 2, 3, 4, 5, 6, 7. So 10 to the 7th. So that'll show up here at the top. So let's let the computer show us. 7.62 times 10 to the 7th. And that's what we got using the first method as well. And either method is fine. You can choose. Let's try another one. Method 1, subtracting with scientific notation. There's our countries again. This time we want to see how many more people live in the US. How many more people live in the US than in Canada? Okay, so we're going to do United States minus Canada. First, we have to rewrite each number in the same power of 10. Again, I have a 10 to the 8th and a 10 to the 7th. I'm going to increase my 10 to the 7th because then I know I move my decimal to the left one and I don't get confused. Convert Canada's power to 10 to the 8th. How do we do that? I showed you previous slides. Move the decimal 1 to the left, and then we increase the power to 10 to the 8th. And moving it one place, decimal goes left 1. We end up with 0.338 times 10 to the 8th. That should be pretty familiar to you by now. And then what do we do? Step 1, we write them in the same power of 10. We subtract the multipliers. Canada and the US is going to go above Canada because the US has a bigger number. And we subtract. Remember, we should be lining up our dot. Mine aren't lined up. So I'm going to actually do this to the right here. 3.1 and then the 0.338 should line up like this. And I do want to show you this because sometimes it's confusing with subtraction of decimals. I have nothing here. I can't subtract 8 from nothing, so I have to put 2 zeros above here like this. Can't take 8 from 0, can't take 8 from 0. I can change this to a 0, borrow from the 1. This becomes a 10, and the number next to it becomes a 9. How do I know that? Because if I have many zeros in a row, the end 0, the farthest right 0 becomes 10. All the other zeros next to it become 9s. So 10 minus 8 is 2. 9 minus 3 is 6. And now I can't take 3 away from 0, so I borrow from the 3 and make it a 2. There's only 1 0 this time, it becomes a 10. 10 minus 3 is 7. Put my decimal point there. And then 2 minus nothing is 2. So I should get 2.762. See if that shows up on the computer there. Yep, 2.762. I wanted to show you how to do that so you don't forget. It's been a year since you've probably done subtracting of decimals. Okay. Then we adjust the final answer to scientific notation if necessary. So the multiplier is between 1 and 9.99. Well, 2.762 is already between 1 and 9.99, so we're done. It's just 2.762 times 10 to the 8th, right? Because we changed them to eighths. So there it is. Method 2, we're going to write them in standard notation first. So write each number in standard notation. Canada is 33,800,000. The US is 310 million. Oh, it's 33,800,000 and the US is 310 million. And I have the word UA. I just noticed another should say USA. USA. There we go. Fixed it. All right, now we subtract. Now it says US. Find the sum. Oh, find the difference. Didn't change that either. Find the difference of the numbers in standard notation. So we subtract. Get 276,200,000. We have to rewrite that now in scientific notation. We have to get a number between 1 and 9.99. You'll hear that a lot. So I start here and I jump 1, 2, 3, 4, 5, 6, 7, 8. 2.762 times 10 to the 8th. That is what we will get. And there it is. Same as the previous method, the same answer. So you might want to try a couple of these by doing both methods and checking to see that you did it right? That way you know if you got the same answer for both methods, you probably did it right? Okay. Now it's your turn to try a subtraction problem. See you in a minute. Welcome back. Okay, your homework is on Google Classroom, and I think that's it. I'm going to say goodbye. Bye. See you next time.